it's all right. Thanks. Hi, everyone. Can you hear me? Good. Okay. Yeah, it's all right. Thank you. So, welcome on my first ever RoboCon presentation here today. Thank you. Which is, as Antti said, transforming robot framework results for the purpose of integrated reporting. It's a bit like an introduction to the topic, but also sprinkled with some information about tools built in the robot framework API. My name is Adam Mikulka. I'm from the Czech Republic. I work at Česká spořitelna, which is the biggest bank in our country. And also a fun fact that it's maybe the oldest financial institute in our country as well. Just recently, Česká spořitelna celebrated its 200th anniversary from 1825. So it's been a while. I worked there at the Center of Expertise in Testing when me and my colleagues try to help other teams in our company with test automation and performance testing. We have over 100 or more so applications and modules in our bank, and each application has its own team which is responsible for quality assurance of that application. So me and my colleagues strive to help these teams achieve the excellence in testing by doing standards, methodologies, and tutorials. But back to the topic at hand. Why am I here today talking about the integrated reporting? And what is the role of the integrated reporting? As you might know, as you should know, or already know, Robot Framework has very detailed and visually responsive reports. All the information about the execution is in these reports. But sometimes these files can get quite large, and storing them for the purpose of release review or traceability can get sometimes very complicated and not so efficient. So in the end, you will start to extract and modify some information from the robot framework to some other tools, like maybe a test management tool or a reporting portal or something other than that. So the role of the integrated reporting is to make the approach to test reporting more cohesive, easily accessible, and efficient for all the stakeholders in the company, from development across testing to business side. And the benefits of the integrated reporting can be centralized data on one access, on one place, where you have all the data from various sources. Traceability. You can link your test results to other issues like requirements, release versions, or defects found, date, and so on. If you have the traceability, you can identify trends and areas for improvements as you look throughout your history of the test results. This all leads to the better and improved decision-making regarding the software quality and the release readiness of your application, and maybe about the whole testing approach. All this combined is just to make the test reporting more efficient and simple and easy to maintain. But not all test management platforms and reporting portals support the robot framework format, output format. So how do we extract and modify the execution information from the robot framework to be compatible with our test management platform? What tools are there built in the robot framework at our disposal? I try to separate them into phases It's like a subjective separation from me, so nothing set in stone. But the phases are what tools you can use before you run your test suites, what can you use during the execution, and what can you use after the execution is completed. I will just try to describe a few built-in tools. I have an advantage that some of the tools were already mentioned here by Pekka at the previous presentation and also by other speakers yesterday. So in the phase before the execution starts, you have a parser. Parser is used in the robot framework to parse your source files and get the data model object of your test suites for the purpose of the execution. But you can also make your own parsers when you want to have your test cases written in different formats. Something like Daniel did for the Gherkin parser. Then you have a pre-run modifier, which is a tool which can modify the parsed data model before the execution really starts. So you can dynamically add new test cases, maybe rename your test suites, and so on. It's used as an argument when you call your robot command. Then also one thing I want to mention is a model transformer, which is very handy with the combination of the parser because you can make some changes to your source code, to your source files, or maybe create new source files with new test cases. Okay? I think this one is also used in RobotID by Bartholomew to format your source files. Then can be, of course, other tools, which I forgot to mention or just didn't know about, or some other third-party tools which you can use before the execution starts. In the second phase, during the execution, you have listeners. Listeners are custom functions triggered by certain events during the execution. So you are able to change some objects during the execution, like fail a certain keyword on a certain condition, or maybe add a new keyword to the test case during the execution. There are also libraries. Libraries can have direct access to the robot framework instance during the execution. For example, to get a value of a global variable. Or also can serve as listeners themselves. Sometimes it can be handy when you want your library to do some cleanup every time a test case ends. Maybe close some connections to some API services or something like that. Then again, there can be some other tools in this phase. After the execution is done, there is a pre-rebot modifier, as Pekka also said, which can be used for the output files to change the structure of your result files or your output HTML file. It is also used as the pre-run modifier as an argument, but now when you call a rebot command. Then there is a result visitor, which is a bit low-key class. It is used in the pre-rebot modifier. But what the visitor does, that when you are working with the result files, you transform them into the result object model. Then you are working like in a Python model with this structure and you can modify it. And the result visitor works a bit like a listener, that it can traverse through this result model, and at certain events, it can do some stuff, like when a keyword ends or when a test case ends. And then after that, you have also some built-in parsers for output XML files or for the newly added JSON output file in the latest Robo Framework releases, or maybe some other third-party tools to work with XML files. Now, I will try also, forgot there's one thing also, that all of these tools are under the umbrella of the Robot Framework API at your disposal in the Robot Framework. Okay? So on the next few slides, I will try to describe a listener, Pre-Rebot modifier, and a result visitor a bit more, just for the purpose to how to modify your Robot Framework execution results. So at first, an intro to the listeners. Listeners, as I said, is a mechanism to hook custom code to specific events during test suite executions. Such events can be a start or end of a keyword, start or end of a test case, or start or end or of some other Robot Framework structure, like var syntax or a for cycle or something like that. You can also have events for when the library, resource file, or a variable file are imported. So, for example, as I said, you can make some adjustments in your custom code to monitor what keywords are being called during the execution. The key takeaway here for you is that there are two versions of listener interface available in the Robot Framework right now. There is a version 2 and a version 3. Version 2 is mostly used for passive reading of the execution result. The execution. So it is used for the purpose of monitoring or reporting what is being done and called during the execution, and what values are contained in during the execution. Version 3, on the other hand, is a bit more sophisticated, and can also be used for active modification of the execution. So you can add new tests on the fly, fail at certain keywords on certain conditions, and so on. In the end, we will end up with a custom file, Python file, script, where the listener is defined. And to activate the listener, we will just reference the listener in an argument when we call a robot command, just as is shown on the grayed out example down below. Next one is a Pre-Rebot modifier. As I said before, it is only used when you are calling a rebot command. And what it does, that it gives you a possibility to modify the structure and content of each test suite, test case, or a keyword, and even statistics and other stuff in the result object model before Rebot merges or generates new output files, like a new HTML file or a new XML file or a new JSON output file. The Pre-Rebot modifier is implemented in a form of a visitor, because which are inherited from the Robot Framework API. And these visitors are used to traverse these object models. So you can have some visitors to traverse the resource model, object model, when you parse the resource files, you can have visitors to traverse the running model during the execution. And here, in this case, we have a visitor which traverses the result structure of a test suite. So what we can do as with the listeners, we can read or modify objects on specific events from this result structure object model. So maybe we can read some information about the keywords that were executed, when they were executed, what is the test suite structure, what test cases were contained in this test suites, and so on. As with the listeners, you will end up with a Python code where your modifier is defined, and to activate it, you will just also reference it on the command line as an argument when calling a rebot. So the last but not least I want to talk about is one of the visitors, and that is a result visitor. Result visitor is one of the available visitors, as I've said, in the Robot Framework API family, but it is mainly used as a base for the Pre-Rebot modifier or some custom script if you want to run the result visitor outside of the rebot. And it is used to traverse, as I've said, the result object model for the purpose of analysis and modifications. And also, as with the listeners, a custom code can be hooked on specific events when the visitor traverses through this model. So you have events like start and end of a test suite, test case, or a keyword, but you also have a new events at your disposal, like when statistics are started to being put together, or when an error starts or ends. But here is a key difference when you are using a pre-rebot modifier and a result visitor alone outside of the rebot, that the visitor just traverses the result object model, which is like a Python thingy. But to get the result object model for the result visitor, you will need to parse the output XML file or the output JSON file first. But there is a dedicated parser in the Robot Framework family for that, so you don't have to write your own parser to do that. Okay? And as the previous examples, we will just end up with a custom Python script where our visitor is defined and events and what we want to do is defined. And we can just call it with a Python command. So this visitor will just take this output XML file and maybe make some modifications to it. Okay, that was a lot of theory. Now let's go practical. Imagine that you have already a test management platform implemented in your company, where you track all your test results and test statistics and test cases from the automated test and also from the manual testing. So, but also another thing is that this test management platform already supports importing results from the robot framework. So it supports the output XML file or the newly added JSON output file. So in the end, you will just take this, after the execution is done, you will just take the output XML file and maybe import it to your test management platform or reporting portal through some REST API service, or you can maybe do it manually through the web page. And after you do that, you will get something like this, which at the first glance doesn't seem very intuitive, right? For someone new to the robot framework or for someone new to the test automation. But maybe, on the other hand, someone experienced with the robot framework can look at it and think, okay, I have some keywords here in the test case, which were executed. I have also the duration and the status for each keyword. Maybe some var syntaxes were also called with certain arguments. And maybe the indenting of the keyword resembles that the keyword is a child of another keyword above it. Okay? But someone new to the test automation does not have this knowledge. And if you have a long test case and a lot of levels of indenting and user keywords, it can get a bit complicated. So in this exercise, what we would like to do is to flatten the top-level keywords through some robot framework tools to move from this to something simpler like this, where we can see only the top-level keywords at our test case, and it is much more simple and streamlined and easier to understand what the test case does. I've made some simple test case. It doesn't really test anything, just do some stuff. So here you can see that the first step of the test case is open the Robot Framework web guides. And the next step is search a topic listeners. But how can we do that? I've prepared 3 simple solutions, which are not supposed to be considered as the final solution or the recommended solution. It's just for this presentation, but they will do. The first solution is using the listener. So I've defined a simple listener which hooks my custom code on an event named end keyword. So something like Pekka also showed. So every time a keyword ends, this function in Python is called. I'm also referencing that I am using the Robot Listener API version 3 because I want to make some modifications to the keyword. Okay? And what the function does here. It just checks that if the parent of that keyword is an instance of a test case, then I know that this keyword is at the top level of the test case. So I want to work only with these keywords in this scenario. And maybe I also know from the Robot Framework user guide that there is a dedicated tag, keyword tag, for flattening Robot Framework keywords. So every time I ran a test suite and there are keywords with this tag, the body will be removed or hidden from the output XML files or the report HTML file. Okay, so this listener does a basic thing that whenever it comes across the keyword which is under the test case on the top level, it will add a new tag called robot:_flatten. And I will hope that the Robot Framework does the rest of the work for me. Okay? Right? Or no? Well, not quite so. In the end, I will end up with an output file where the top-level keyword will have a new tag called robot:_flatten. But they will be not flattened, or the body will still be contained in these keywords. And that's because the flattening of the keyword during the execution is done way before my listener is even called. So this can show you that sometimes during the execution, Robot Framework simultaneously puts together the output XML file in the background. So it can be sometimes complicated to remove or hidden some information. You can change values, that can be a bit easier, but to hidden something which was maybe already written in the output XML in the memory, that can pose a challenge. So to end up with to make this not so optimal solution work at the end, I will just need to call a rebot and say, take my output XML file from the execution and create a new flattened output XML file. And by flattening a keywords which have the given tag. So then I will end up with an output XML file where only the top level keywords are contained and every lower level is hidden. Then I can take it and import it to my test management platform. And I will get the desired result as I've shown before. I don't have much time. How much time do I have left? 4 minutes. Okay. Yeah, just one slide, this last slide, thank you. The next solution I try to prepare is with the result visitor. It works a bit similarly as with the listeners, but I will just define my custom class which inherits the result visitor. So everything the result visitor from the robot framework can do, my visitor can do as well. And in my visitor, I also define a hook on a specific event as with the listener in the previous slide. And that event is end keyword. But now I won't add a new tag, on the other hand, in comparison with the listener, but I will try to remove the whole body of this keyword. So every time I will come across a keyword which is on the top level of a test case, I will say to the visitor will remove the body of the whole keyword. And what that does is that every structure or another keyword hidden in this user keyword will be removed or hidden from the output XML file. And as I said before, the visitor only traverses through the result model. So I can't just give him a path to the output XML file and say, do your thing. I will have to parse the output XML file first. And for that, you can use the execution result, which is the parser dedicated for parsing the output files. So in the script actions, you can see that only like 3 steps are made in this my script. And the first step is like parsing the output XML file. I will get the result object model, and I will visit this result object model with my visitor and let the visitor do its thing. After that, I get the modified result object model, but it's still just a Python object model. So in the end, I will have to save it into a new output XML file for some other tool to work with. Okay, so you can find all the 3 solutions. I will go back to the third one on my GitHub repository, which can serve you as a playground to maybe try your own things with this API and the modifying of the result output files from the robot framework for your own purposes. And maybe if you have some ideas what else can be done through the robot framework API with these built-in tools, you can make an discussion on the repo, or have an issue if it doesn't work maybe. But I will let the last slide here sit there for you, where I didn't use any built-in tools from the Robot framework, but I use a third-party parser from the XML file. And you can just look at it and think for yourself, what are the dangers here when we are using a third-party solution for parsing the XML file, okay? And maybe if you will come up with some possible risks in this approach, you can just come to me after the break or during the break. And if you want to discuss it, you are welcome to do so. So thank you.
Thank you, Adam. We have time for one short and good question. So who's going to ask it? There's, yeah.
Yes. You mentioned in the beginning that you might have to do some post-processing of your robot results to integrate them into some like test result management system or like centralized reporting system. But sometimes these systems also have plugin interfaces or something like that. So how would you determine if it's better to start modifying your robot results to fit the system, or if it's better to modify the system to fit native robot results?
Yeah, that's a really good question. It depends on the whole solution of that test management platform. If it's your own company test management, like you have a dedicated team which develops this, maybe it is easier for them to improve the API for importing the results and add some more arguments when you are importing the results through the REST API that, okay, now I want to import it, but also do some flattening of the keywords, or only import the top level keywords, right? So the test management platform then can do the stuff for you, like behind the curtains. But sometimes you don't have that, and you have like test management platform solution from another company, which maybe prioritizes its own features. And when you propose to make some change, it will maybe take a time before they can deliver it. So if you are skilled in a robot framework and you know what to do, maybe it only takes an hour to just make a temporary result visitor or something like that for the purpose of your integration reporting. Okay? And then after they develop their own solution, you can just maybe your own solution, put it aside or use it for some other things.
Thank you, Adam. You can ask more questions from Adam in the speakers' corners during the next break. Welcome to the team.
Thank you very much.
First talk abroad.
Yeah. Thank you.
Hey, thank you. Excellent talk.